So the graph of cosine of x looks like it starts at 1, except this is 3 cosine of x. So this starts at 3, the peak of its amplitude, and then it has a period of 2 pi. So this thing should start repeating itself at this point, once we're at 4 pi over 2. So it should, let's see, should be crossing here, should be at the bottom at pi, and then it should be crossing back up here and then reaching its peak at 2 pi. So we're asked between pi over 2 and 3 pi over 2. So this region right here, they want to rotate this around the x-axis. So the rotation is going to be going in this direction. So in Calculus 1 at the end of the course, what students usually do is they study two different methods for calculating the area of that region. One method is to consider the three-dimensional shape being cut into slices so that you have just a circle. If you can come up with an equation for every one of those circles, you can integrate that equation from pi over 2 to 3 pi over 2. And thereby going from 2 dimensions, a circle, integration brings you up a dimension into the third dimension, so you have volume. So that's the disk method, and an extension of that is the washer method, where you cut out you cut out an infinite amount of disks. So you got to come up with an equation for a circle for all those disks. And then we also have the shell method. The shell method is a way of coming up with an equation for all of the different types of right cylinders that we could construct to represent this volume. Okay. And then if you were to integrate a three-dimensional idea like volume, that would bring you into the fourth dimension. That's not what we're looking for. So what you do with the shell method is you come up with an area you come up with a surface area for all those different shells. That's a two-dimensional measurement, surface area, and then you integrate that, bringing it into the third dimension, giving you volume. So for me, I'm going to use the disk method here. I'm thinking about it. The shape is going to come around the other side, and it's going to be revolving, so it makes 3 dimensions. To come up with the formula for the two-dimensional circle that would happen right here, then I need to know the radius. And that's what this equation gives me. It tells me the radius because it's telling me a y value. It's telling me a distance from the x-axis to the bottom. Okay. So the radius is going to be this. And the equation of a circle is pi radius squared. So that's the area of all the different types of circles. It'd be this one too. It'd be a circle that came from slicing the volume this way. And so we need to make that three-dimensional. We'll integrate it from pi over 2 to 3 pi over 2. So we could take out all the constants. This is 3 squared, so that's going to be 9 pi. We're integrating pi over 2 to 3 pi over 2 of cosine squared x. So we just need tricks from pre-calculus to do this one. Sorry, one second. Okay, sorry about that. So we are integrating from pi over 2 to 3 pi over 2. Cosine squared dx, there's no substitution that we could make with like u substitution or tricks like that, but we can use a pre-calc idea that the power reduction formulas say that cosine squared is the same thing as 1 plus cosine of 2x over 2. And that's something we can integrate. So this is 1/2 plus 1/2 cosine 2x, and this is all with respect to x. The great thing about the integral operator is it's a linear operator. It acts kind of like the distributive property. So we can just consider integrating 1/2, that's 1/2 x. That x is not in the denominator though. There we go. And then integrating this term, the derivative of cosine is negative sine. So the antiderivative of cosine would be sine. But we need to consider what would happen with the chain rule. Because right now, if I take a derivative of this, the 2 would come out from the chain rule and cancel out, so that we need to multiply this by another 1/2, so in other words 1/4. So this is the antiderivative of this. And then we evaluate this integral. The limits of integration are pi over 2 to 3 pi over 2. So we got 9 pi. So plugging in the limits of integration, I'll do 3 pi over 2 first, obviously. So that's 3 pi over 4 plus 1/4 sine, and then 2 times 3 pi over 4. So that's going to be 3 pi. And then we subtract what happens when we plug in the lower limit of integration. That's pi over 4 plus, if I plug pi over 2 in here, I get sine of pi. This is a 1/4. I don't think it's going to matter though, because yes, no, it will. It will, because sine is 1. Sine of pi is 1. Okay, so putting that all together, calculus part's done, right? Sine of 3 pi. If you're not sure, 3 pi is, 2 pi is coterminal with 0, right? So 3 pi is just another pi rotation here. Brings us right here. Sine is always the y coordinates on the unit circle. So the angle 3 pi is right here. That y coordinate is 0. So this whole thing is 1/4 times 0. Then we're subtracting pi over 4. Then we're subtracting, if I got that right, if that's sine of pi. Oh, I said that wrong earlier. Sine of pi is right here. That's also 0. So it looks like we got 3 pi over 4 subtracted by, that's 2 pi over 4, so that's pi over 2. So we got 9 times pi squared. So that's going to be pi squared, because pi times pi. And then that was a 2 on bottom. I did some mental arithmetic there. Let me just double check that. That's pi over 2 times 9 pi, so that's 9 pi squared over 2. Yeah.